Welcome to the first video of the ethanol and biofuels chapter. In this video, we're going to cover the very first syllabus dot point, which says identify the IUPAC nomenclature for straight chain alkanols from C1 to C8. So first, we got to make sure, obviously, that word identify means we just have to be able to know what the nomenclature is, state facts. We will talk about the IUPAC nomenclature and give the nomenclature for C1 to C8 of alkanols. So these are alcohols. These are not alkanes, these are alcohols. But before we start to talk about alkanols, we'll go over what alkanes were again. Alkanes were these ones. So methane, ethane, propane, butane, pentane, hexane, heptane, and octane. The ones that end up with that ane suffix. And that meant it was an alkane. And alkanes, for example, ethane, means that in this case it has ethane. Eth means two carbons, so it has two carbons in its chain, and they're connected by a normal bond, and surrounding it is hydrogens, so hydrocarbons. So no double bond, just a normal bond between two carbons and the hydrogens connected to it. And for ethane, so two carbon ones, the chemical formula was C2H6, and that makes sense because the general formula, so this is the general formula for all alkanes, is CN H2N plus 2. So for example, if we put that C2, so instead of that N, we have 2 here. That means if you have 2 carbons, you have 2 hydrogens times 2, so 2 times 2 plus 2, which is 6. So for an ethane, if we use that formula, we should get C2H6, which we do in this case, but we can use this formula for any of the other ones. Octane would be C8, would be 8 here, and you would have 8 here, and you'd have 2N, so 2 times 8 here, instead of 2 times 2, plus 2. So in this case, 2 times 8 is 16, plus 2 is 18. So that would be 18. So if we use that formula, we would have gotten, for octane, we would have gotten C8H18. So we can use this formula to get the actual chemical structure and chemical formula for all the different alkanes. So with this, the reason why I made them in different colors is because each of these prefixes, which is the first part, the colored part, refers to how many carbons are in the chain. So meth stands for 1, so 1 carbon. Eth stands for 2 carbons in the chain. Prop stands for 3 carbons. But stands for 4 carbons. Pent for 5 carbons. Hex for 6 carbons. Hept for 7 carbons. And oct for 8 carbons. Remember that because we're going to go over that in a second again when it comes to alkanols. So these were the alkanes. Right? Alkanes refers to this chemical formula, the general chemical formula. And generally, these alkanes don't have a double bond or anything else but hydrogens attached to their carbons. Now, alkanols is slightly different. Here we have alkanols. This is how you write the alkanols. So again, you have that same prefix, which is these are the colored ones here: meth, eth, prop, but, pent, hex, hept, and oct. So meth, an, nol, that means it has 1 carbon in its chain, but then we have the additional part of that ol as well at the end. So each has an ol in the end. And that ol refers to it being an alcohol. So that ol is the alcohol. So all of these are alcohol groups or hydroxide groups, the OH groups. So if we look at ethanol, remember ethane just had 2 carbons and 6 hydrogens, whereas ethanol has 2 carbons, but it has 5 hydrogens plus this OH group. So one of the hydrogens got replaced by an OH group. And that's the major difference. So if you look at its structure, if you compare these two, we have C2 for both, then we have H5 for this one and an OH. So it has 6 hydrogens, but also has an additional oxygen, whereas the ethane only has 6 hydrogens. So we've added so this is new, the actual oxygen is new. And all alcohols, all alkanols, they have this OH group in their chain. Now this was the example of ethanol, but you can get the same for methanol. Would be with 1 carbon, but it would have an OH group. Propanol would have 3 carbons. It would have an OH group somewhere sticking off. And the general formula for alkanols is CN H2N plus 1 OH, right? So, for example, again, ethanol, we've got C2. So if we have C2, so that if that N is 2, then we get H2 times 2 plus 1, so H5, which we have here as well, H5, plus an OH group, which we have. So we can use this chemical formula to get ethanol, but if we use that same one with any of the other ones, we can also guess the chemical formula for the other ones as well. And there's 3 different things we need to do when it comes to naming alkanols. We need to be able to choose the correct prefix. So prefix, pre means before, so the thing that comes before the ol part. So from meth means 1, oct means 8, so we need to find how many carbons it has. And once we know how many carbons it has, we have to be able to choose the correct one. So you guys need to remember C1 to C8, what their prefixes were for those different numbers. Then we have to replace the E, so ane, for the methane. We replace that E here with an ol. So methane is not methane, but methanol. Right, the E is gone and it's replaced by an ol. That was one big difference. Those 2 steps we have to do when we name alkanols. And last but not least, we have to be able to guess, we have to take into consideration the position of the OH group. So, for example, here we've got 1, 2, 3, 4, 5 carbons. So 5 carbons, so C5, that's a pentanol. But if you look at the OH group, in this case, the OH group is right here. But we have to actually take that in consideration when we name this molecule. So we can't just say pentanol. If we write pentanol, we won't be fully correct, because what we have to do is we have to start from the carbon that we're closest at. The counting needs to start at the carbon that we're closest, which is this one here. Because here, if we count here, it's 1, 2, 3, 4. So 4 carbon away. So it's further away than from this one. If we start counting from here, it's 1, 2. It's closer. Always have to start from the closest. Start counting from closest carbon. Then we have to count and see how far we go. So in this case, it's 2. And then we do it one of 2 ways. We can either name it, in this case, 2, because it's 2 away from the first, 2 pentanol, or we have to be writing this one way, or the other way is pentan. So pentan, and before you write the ol, you write 2 ol. So these are 2 ways you can write the same thing. All that's saying is we have pentanol, which means we have 5 carbons in our alkanol, and our alkanol group, so this group here, the OH group, is our second carbon. That's what that means, 2 pentanol. But we can write it as this, or as this. So 2 pentanol or pent 2 ol. Both mean the same thing. So I'll go over it again. When we name alkanols, we have to know their suffixes and their prefixes. Prefixes are the things that come before the actual word, and suffixes are the things that are at the end. So prefix is usually how many carbons it has. If it has meth, that means it has 1 carbon in its chain. Oct is 8 carbons, and all the other ones are everything in between. You gotta know that, but you also have to know that you have to replace on the ane, the E has to be replaced with an ol at the end. That's for any alkanol. And you have to find out what position the actual OH group is, and take that into consideration when you name your actual alkanol. Right? So 2-pentanol means your OH group is at the second carbon. Penta-2-ol is just a different way of writing the same thing. They both mean the same thing. So those 3 steps are quite important. So I hope that was useful.